Welcome to our quantitative methods class, where we're going to learn what is called Introduction to Statistics. So before we go very much far, we're going to just give you a snippet of what we're going to cover in here. So under Introduction to Statistics, we're going to look at what is called data presentation. We're also going to look at what is called descriptive statistics. And finally, we're going to look at some probability. It is important to understand this segment in your quantitative methods. Firstly, to start with, data presentation is very important because you will need to be able to present information in a manner that even a literal layman is able to understand. So let's go to our grade 4 to understand a few polygons before we go into answering a few questions. So I'm going to enlist 6 polygons that I need you to remember. A, B, C, D, E, F. So I'm going to ask you to just identify any of these polygons that you can see and differentiate them where possible. Okay, so we can start. Polygon A. What is polygon A?
The pie chart.
It's a pie chart, okay? And what is polygon B? Polygon B, what is polygon B? Quickly, let's start from what we all already know.
It's a histogram.
The histogram, okay. Then polygon C.
Histogram. Polygon C.
So this is a histogram. And polygon C.
The bar graph.
It's a bar
It's a
graph
bar chart.
about the line that joins the midpoints of the histogram. E. What is polygon D? It's an ogive.
Hold on.
And what is this structure we're able to see at polygon E? Polygon E. It's a box whisker plot.
Box and whisker plot.
And what is polygon F? The cumulative what? Frequency. Cumulative frequency graph. Okay. Now, we're going to look at, under data presentation, 2 types of information. There's what we call quantitative data and qualitative. Can somebody tell me what is quantitative information and what is qualitative data? What is quantitative data and what is qualitative data? Anyone? Let's quickly move on that. What is qualitative data and what is quantitative data? Okay. So whenever we're dealing with quantitative data, we're simply looking at the measures of values or counts that can be expressed in numbers. So these are measurable variables, okay? Then when you're dealing with qualitative data, we are looking at what? Types that can be represented by names, symbols, and types. So quantitative is measurable, whereas qualitative is non-measurable. So under quantitative, we're going to discuss a few types that are represented by quantitative. We can measure them. So we're going to look at what is called discrete and what is called continuous. Discrete are simply countable numbers that are not recurring. Okay, when we're dealing with continuous, we're looking at numbers that have decimal points in short. So I'll give you a few questions to describe quantitative and qualitative information. When we're dealing with qualitative, we're looking at measures of types, and these ones may be represented by a name, by a symbol, by a number code. These are what we call qualitative data. So they're mainly about what categories of variables. So under quantitative, we are going to discuss what is called discrete. And we're also going to discuss what is called continuous data. Discrete, we're looking at the numbers, for instance, how many you are in a family. Yeah, 7. You can't have 7.5. Yeah, 7. For continuous, we're dealing with what? Recurring. You have numbers in between these countable numbers. So between 0 and 1, we have 1.1, 1.2, 1.3. This is continuous. For instance, weight, time, etc. Then here we're going to look at nominal and what? Ordinal. So we'll quickly go through a few questions, then we'll proceed to measures of central tendency. So we're given a question to say, consider the following variables, state whether this is quantitative or qualitative. You could also state whether it's discrete or it is continuous. So here, a weight of a baby, what type of data is it? This is quantitative but continuous. Interval could be obese or underweight or normal. There are those red flags that we have. The country in which you're born, what type of data is this? The country in which you're born, that is qualitative but nominal. Nominal is as good as what? Discrete. You can't be in 2 countries. You are born in 1. But tribe can be ordinal because you could be Bemba and Lozi at the same time. Then the temperature at Mount Makuru, what type of information is this? Quantitative and continuous. The number of appearances that our women have gone to the women football league, that is what? Quantitative and discrete. All right, that is quantitative and discrete. Any questions so far before I go to the next stage? Any questions before I go to the next? Maybe I could ask you to describe this information here. Let's classify the kinds of information here. The number of female professors in mathematics. Quantitative or qualitative?
Quantitative.
This is quantitative. The ladies, the country of birth for a graduate student. Quickly.
Quantitative.
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 Qualitative.
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 Qualitative
Okay.
for the country.
Favorite sport.
Qualitative.
The gent. Favorite sport.
Qualitative.
Qualitative. The ladies, gasoline remaining in your tank.
Qualitative.
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 Qualitative or quantitative?
Quantitative.
Quantitative. How about the
Quantitative.
brand of computer owned by a student?
Qualitative. Qualitative.
Quantitative.
Qualitative, okay.
Qualitative.
All right, so at least we're able to identify that. Now, we're going to quickly go to measures of central tendency. So you'll be given numbers, for instance, as follows. We have 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have numbers like 4, 2, 9, 3, 6, 3, 5, 20, 8, 6, and 9. So the first thing whenever you're given such information is to rearrange it, starting from the smallest to the biggest. So let's rearrange them. What is the smallest number we have?
2.
We got 2, then
3.
3, then another 3, then
4.
4,
4,
then
5,
5, then
6,
6,
6. 6.
8, then 8,
9.
9, then another 9,
How many nines are there?
20. 2.
There are 2 9.
So I mean we have 1, 2,
Then-
3, 4, 5, 6, 7, 8, 9, 10, 11. So our n is what? 11. So like I said, please, let's start with what we already know. The measures of central tendency, you can choose any. So let's start with range. What is a range? The difference between the highest number of x and the smallest number of x. So what is the highest number of x
20.
20.
and the smallest?
2.
What is our range?
18.
18.
18. All right. Then mode is the most frequent. Which numbers are appearing the most?
6 and 9. 3, 6 and 9.
3, 6, and
And
9. Do we agree with her?
yes,
Right. 3, 6, and 9. Okay. Then we go to the quartiles. We have what we call quartiles. Quartiles are a quarter. So I want you to identify there's a first quartile, second quartile, and the third quartile. A quartile is a quarter, it's like 25%. So a quarter, we add another quarter. So 25 plus 25 is 50, so it goes to half. 25 plus 50 plus 25 is 75, which is like 3 quarters. So these are quartiles. For ungrouped data, we just multiply by n plus 1. So to find the first quarter, we're going to find a quarter of n plus 1. What is our n? 11. 11 plus 1 is 12.
12.
So what is the quarter of 12?
3.
4.
3.
3.
Eh,
A quarter of 12 is 3. So we look at the third position. 1, 2, 3. What number is there? Coincidentally, it is 3 itself, right? So that is what we
Yes.
call our first quartile. The second quartile, what formula do we use? Half. Half of n plus 1. So 11 plus 1 is 12. So half of 12,
Okay.
6. So let's go to the 60th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 60th position is what?
6.
Coincidentally, not always that it will always be the 66. Yeah, so 6. All right. Then we go to the Q3, which is the upper quarter or the third quarter. So this is 3 quarters of what? N plus 1. So 3 quarters of n plus 1 is the 9th position. Which one is the 9th position?
9.
9.
9. So the second quartile is also called the median. So we said the range is the difference between the highest value of x and the smallest value of x. Then we also have a special range which is called the interquartile range. We denote it by IQR. Interquartile range is the difference between the highest quartile, which is Q3, minus the lowest quartile, which is Q1. So what is our highest quartile? 9. And our
9.
smallest quartile is 3. So what becomes our interquartile range?
6.
6.
6. Then we also have what we call the semi-quartile range. Semi means half. So half of the interquartile range, what is the half of the 6?
3.
Half of the 6 is 3. So 3 is what we call our the semi-quartile range. So let's do a quick, can you remember? Right, so we have quartiles, the first, second, and the third. Q1 is called the lower quartile or the first quartile. Q2 is called the median or the second quartile, and Q3 is called the upper quartile or the third quartile. How do we find the first quartile? A quarter of n plus 1. What is n? N is the number of observations. How many are they? 11. So 11 plus 1 is 12.
12.
So a quarter of 12 is 3. So we go to the third position, 1, 2, 3. So we picked this. We don't call here because this is not what? Arranged. Then the second quartile is half of n plus 1. So half of 12 is 6. So 3, 4, 5, 6. So this is the 6th position. Then the upper quartile or the third quartile is 3 quarters of n plus 1. So 3 quarters of 12 is 9. So 6, 7, 8, 9. So this is what we find as our what? As our upper quartile. Then the difference between the upper quartile and the lower quartile is called the interquartile range. So this is the interquartile range that we found as what? As 6. Then half of the interquartile range, it's called semi-quartile deviation or semi-quartile range. So half of the 6 is 3. Anyone behind so far? Are we together?
Yes.
All right. So now we can go to this creature here. It's called the box whisker plot. The box whisker plot has 5 key elements: the minimum value of x and the maximum value of x. And we also have the Q1, Q2, and Q3. So the smallest number was 2 and the highest number was 20. Isn't it?
Yes.
20. Q1 is 369. So 3, 6, 9. The interquartile range was the difference between what? The highest quartile, 9 minus 3, which was 6. So we need to identify the extreme values. How do we find the extreme values? On the lower quartile, we subtract 1.5 times IQR. So sometimes I advise that you can get the correction term. This is called the correction term. Just simply multiply this answer times 1.5. So 1.5 times 6 is 9. So this is the correction term. So to the upper quartile, we add 1.5 times what? Times 6 itself. So what are we doing here? To these 3, what are we subtracting? A 9. Or 1.5 times the interquartile range, which we found as 6. The same as 3 minus 9, which is negative what? Negative 6. So you can draw your number line if you want to identify where's the negative 6. Negative 6 is somewhere here. Then to the upper quartile, the 9 here, we add 1.5. Then in the interquartile range, we put the 6 there. So like I said, you can identify it in advance. This is 9, the whole correction term. So just add 9 plus 9 is 18. Where is the 18? 18 is somewhere here. So any values outside these two is called the outlier. So these are the extreme values. Which numbers are outside this range? Which numbers are outside?
20.
20.
That's 20.
That's
That's 20.
20, sir.
So 20 will be called what?
Outliers.
An outlier. So an outlier is simply an odd one out. How do we identify outliers? For instance, outliers are simply strange things. In auditing, you discover there's an anonymous payment, which is extremely out of range. Or you have an extremely intelligent child and the rest are average. You would wonder, is this really my child? Or you have children who have the same gender and one, maybe it's a lady or a guy, but one is an outlier. Outliers are very important because they help us identify the extreme measures. Are we together? Any questions this far? Any questions?
So are there questions where they just ask you to find an outlier?
Yes. Questions where you need to find outlier. So you cannot find an outlier without finding what we've already found. Any other question? All right.
Sorry, on the formula callings, the first Q1 we did minus, and the third one is plus.
Exactly.
What was the explanation? I missed it.
So after getting this 6, you multiply by 1.5 to get 9. So they're like stretching. It's like probation on this side. So this 9 we add plus the 9 there to get 18. On this one, these 3 we subtract. So if you're extending to see which ones are outside range. So 3 we subtract the 9 to get negative. So on the lower bound we usually subtract, in the upper bound we usually add. That's what happens. It's a rule. Okay. That being said, we now go to the other measures like the mean, the mode. So the values that we had what? So let's add these ones here. So we are supposed to add these ones. Then we also square them as well. So we can square them. This is 2 times 2, 4. Here we have 9, 9, 16, 25, 36, 36, 64, 81, 81, and 400. So quickly help me find the totals. So these are the values of x, and this is x squared.
For x, it's 75.
So summation of x is 75. Then x squared.
$761.
Do we agree? So summation of x is 75. Summation of x squared is 61. So we need to find the measures of central tendency. So there's what is called the mean. The mean is called the average. Our n, how many elements did we have? We had 11. So to find the mean, it's summation of x over n. So we're simply dividing 75 divided by 11. What do we get? 75 divided by 11. What do we get?
Six point 818.
Okay, 6.818.
One.
Then we also have what is called the variance. The variance is given by this formula. Summation of x minus summation of x all squared, everything divided by n minus 1. So 671 minus 75 squared over our n is 11, then here 11 minus 1. So we start from here. What is 75 squared over 11?
$511.36.
What do you get? 11 squared over 11. 75 squared over 11.
511.36.
Okay, 511.36. Okay. So if you can't hear anything, please activate your audio. Those who are using Zoom for the first time, you activate audio. Right. And what do we get? 761 minus 511.36. What do we get there? Then below we have a 10.
249.64. Then divide by 10.
Which gives us what?
24.964.
This is what we call our variance. The variance is given by the symbol s squared. This is for a sample. If it's a population, they use sigma squared. Okay, and the standard deviation is simply the s without the squared. So we get it by square rooting our variance. So what is the square root of 24.964? 4.9, is it? What is 24.964 when you square root it?
4.996.
0.996. So here is just an issue of understanding the formulas. The formulas, sometimes they're given to you, sometimes you need to know them. So summation of x squared minus summation of x all squared over n minus 1. So just need to understand where to place what here. 761 minus 75 squared over 11, 11 minus 1. So when you evaluate this, you get the variance, and when you square root it, it is called the standard deviation.
Excuse me, sir. Is it advisable to round off the standard deviation? Maybe that one in the case of 4.996, can it go to 5?
Preferably leave it to 3 decimal places as it is, unless it was 25. So rounding off may be costly. Preferably leave it to 3 decimal places.
Okay, noted.
Right, then when we go to what we call our coefficient of variation. By the way, variance simply measures how much we're deviating from the mean. So coefficient of variation is the CV. So CV is given by standard deviation over the mean times 100. So our standard deviation is 4.996, and our mean is 6.818. So 4.996 and 6.818 times 100. What do we get?
It's 73.28.
73.28%. And finally, we have what we call the coefficient of skewness. This is given by 3 mean minus a median. You divide by what? By the standard deviation. So our mean was what? 4.9. Our mean was 6.818. Our standard deviation was 4.996. Then our median, remember our second quartile, our median was what? 6. So what do we get as our coefficient of skewness? So whenever the mean is more than the median, it means you have a skewness which is positive. So for skewness, I want you to really comment on the distribution, how it is coming out. If you get a positive answer, it is skewed to the right. If you get a negative answer, it is skewed to the left. If you get a 0, it is normally distributed. Here when it's positive, and here when it's negative. So here we're obviously going to get positive 0 point something, isn't it? 0 point what?
Five 3, 0.53.
So our coefficient of skewness simply tells you whether the distribution is positive or to the right, or whether the distribution is negative or to the left. So sometimes, for instance, if you want to moderate your results and they discover that the distribution is negatively skewed, and a lot of you have failed, they'll need to reduce the pass mark so that it is somewhere normally or as much as many pass. So distribution mainly, you'll be asked to comment. The comment will definitely simply be you commenting whether it is negative or positive or it is normally distributed. So this is usually the first question of your final exam, descriptive statistics. So you need to understand these parameters that we have discussed here. So it is carrying 25 marks. You need to really take your time to understand this. So I'll send you homework, which I will need you to answer. This will be a homework question where given these values here, you'll be asked to find the mean, 2 marks, the variance, 3 marks, the standard deviation, 1 mark, the median, which is the second quartile, the mode, the first and the second quartile, and find whether there's an outlier. So from what we've discussed, this is very doable. Unless there's any part that you did not understand. Of course, there's a shorter way of using the calculator to find the summation of x and summation of x squared, which I'll explain during the weekend. But for now, if there are many like that, you can literally do that, but it will waste a lot of your time. Okay. So sometimes you'll be given data that is as follows. You have 0, 1, 0, 2, 0, 5, 12, 11, 19, 11, 20, 25, 26, 25, 24, 28, 33, and 31. So you'll be asked to draw what is called a stem and leaf diagram. So stem and leaf diagram is drawn as follows. The stem is the title of the number. The leaf is the last digit. So we have numbers here that start from 0, 1, 2, and 3. So in order of starting from the smallest, what is the smallest number? We have 0, 1. So instead of writing 0, 1 again, we just write 1 here. And we have 0, 2. So 0, 2, we have 0, 5, 0, 5. On the ones, the smallest we have what? 11, which is this one. Then another 11. Then which one follows? Which one follows?
12.
12,
1, 2. Then which one follows?
19.
19, 1, 9. Then on the twos we have what?
So 20, which is 0,
Then
24,
4, 5,
5, 5,
6,
6, lastly 8.
Actually 8. Then
On the 3s, you have 3, I mean 1, and 3.
so how many are there in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Our n is what? 15. So quick, can you remember who can help us find the range? What is our range? What is the range?
33 minus 1, which is 30.
The highest value minus the lowest value. So 33 minus what? 1,
1.
which is what? 32. Anyone else to try the
Oh,
mode? How do you find the mode?
The most frequent number,
So the most frequent number, which is
11 and 25.
we have 11 here. These 5s here, so this is 25. So 11 and what? 25. This is a
25.
bimodal frequency. So a lady this time, the first quartile, how do we find quartile 1? A quarter of what? N plus 1.
n plus 1,
And our n is what?
15,
So 15 plus 1 is what?
16.
16,
So what is a quarter of 16?
4.
So a quarter of 16 is 4. Is 4 the answer of the position?
The position of the first
Let's
quartile.
count since I already arranged 1, 2, 3, 4. So what number is this?
1.
11,
What is this?
1.
11,
11.
11.
Correct. And the
Oh,
second
because you're
quartile?
adding the stem as well.
Yes, that's the essence, yes. The second quartile is what? Half of n plus 1.
Which is also the mean.
So what is our 16? So half of 16, what do we get?
8.
Eighth number.
8,
So this was the fourth. 4, 5, 6, 7, 8. What number is this?
20.
20,
20. All right. How do you find the upper quartile?
3 quarters.
Good. 3 quarters of n plus 1. So what is 3 quarters of 16?
4.
The 12th. So this is 8, 9, 10, 11, 12. What number is this?
26.
26. Correct. Another question. How do we find the interquartile range?
Subtract the high value from and the lowest value.
Interquartile range is a Q3 minus what?
Q1,
Q1.
Q1. So what is our Q3?
26,
And our Q1?
11,
11,
So what do we get?
15.
15.
15. All right. I have another question. There's a term called the semi-quartile deviation. How do you find the semi-quartile deviation?
You divide the interquartile range by 2.
Divide the interquartile range by 2. Excellent. So the semi-quartile deviation is simply half of what? The quartile range. So half of 15 is what? 7.5. Then how do we find the correction term?
You add 1.5 in
0.5 times what?
interquartile range.
Interquartile range. Correct.
Interquartile range.
So interquartile range is what?
Interquartile
15.
range is 15.
15 times 1.5, what do we get?
22.5.
2.5. Can two people, just two people, explain to us how to do the stem, the box whisker plot? There are 5 things that are important. Number 1,
The interquartile range.
no,
The lowest value
the lowest value of x,
and the highest value.
the highest value, correct,
Then the
Q1.
quartile ranges.
q1,
Q1, Q2, and Q3.
correct. So what is our q1? What is our lowest value of x?
1,
1, and the highest?
33.
33. What is our q1?
11.
11,
q2
20,
20.
and q3?
26.
The correction term, what do we do to these two values?
With the Q1, you subtract 1.5 times IQR.
This is correction term, right? So on this, we subtract. Okay. We're going to get negative 11.5. On the upper bound, what do we do?
Add.
You
We
add
add. What do we get? To the 26, we get what? 48.5.
Yeah,
48.5.
Then we identify outliers. Do we have any outliers in this case?
No.
No.
All the numbers
all
are
within range.
within the extreme values. Okay.
Yes.
All the values are within the extreme two numbers. So this is where our descriptive statistics for the ungrouped data ends. So for the next few minutes, I'll quickly ask questions firstly, if there are anyone behind. Okay. So now the other part of descriptive statistics is called grouped data. So under group data, we'll learn how to find the mean, the median, and the mode. And we'll also learn how to find the quartiles. So to start with, we need to learn how to draw what is called the frequency distribution graph. So you'll be given values as follows. We have 3, 2, 7, 12, 17, 22. And here we could have 8, 13, 18. Maybe I can add 1 additional line. So we could have 27, 3. And we're given frequencies as follows: 6, 9, 12, 8, 4. So we need to come up with what is called the frequency, cumulative frequency. So how do we start the cumulative frequency? We start with the figure that has been given, then we keep adding on. So this 6 comes here, 6 plus 9. What do we get? 6 plus 9, what do we get? 15.
15.
15.
15 plus 12, what do we get?
27.
27 plus 8,
35.
35 plus 4.
39.
39.
So this 39 is obviously the total, which is called summation of F or N. So I want us to learn how to find the mode and the median. So the formula for the mode is simply found by the lower bound plus D1 over D1 plus D2 times height. So mode means the highest frequency. Step 1, identify the number which is highest here. Which one is the highest number here? 12. Okay. The distance going up is called D1. The distance going down is called D2. And the number which is in the lower boundary here is called the L. I repeat, mode means the highest number. So step 1, find the highest number here. What number is the highest here? 12.
4.
The distance above is D1. So 12 minus 3, what is our D1? 12 minus 9 is 3. Then D2 is the distance going downwards. 12 minus 8, what is our D2?
4.
4. Then the lower boundary, just on the 12, you go this side. The lower boundary is what? The number which is at the far end. So this is 13. But if the numbers are not the same, you subtract the 0.5 on the 13. So the lower bound is what? 12.5. The rule. It's actually 13, but we're subtracting 0.5 because we correct it. Then the height is simply the distance between the lower boundaries alone, from here to here to here to here. What is our height? Our height is 5.
Can you go back please on the lower?
So ideally, the first question we need to ask ourselves is, are these classes adjusted? The ideal situation is 3 was supposed to go to 7. Then we start with 7, supposed to go to 12. Then we start with 12, supposed to go to 17. But because this is not happening, this is the pattern. We need to subtract 0.5 here and add a 0.5 there, so that the actual classes that we have are 2.5 to what? 7.5. And here 7.5 to what? 12.5. And here we have 12.5 to what? 17.5. Then here 17.5 to what? Because we're subtracting a 0.5 on each of these ones and adding a 0.5 on each one of these ones, 22.5. Then finally 22.5 to 27.5. So this 13 you are seeing is not actually 13, it's 12.5. But look, these ones are now balancing up. These numbers need to look like a histogram. So how do we find the mode? Step one, the highest number. This is called FM if you like. On top of it, it is F1. Below it is F2. Yes, please, Mr. Simoshi.
So if the mode, the highest number is on the first class,
If we had
what would
18
be
here, we can never have a mode in
No,
the
if-
first class. That's a very good question. You can never have a mode in the first class. So
so it's
if
always in the
our-
middle.
Yes, it's always somewhere in the middle. It can never also be on the last part here. If this was 18, that would be our FM. Our F1 would be 12, our F2 would be 4, then the lower boundary would have been the 18, which is 17.5. So I'm going to use two formulas. The first formula is the easier one for people who don't want to think too much. So 12, the distance above is D1, which is 3. The distance below is D2, which is 4. Then in this same line, the lower boundary, which is adjusted, is what? 12.5. Yeah. Then we substitute. L here will be what? 12.5. D1 is 3 over 3 plus. D2 is 4. And our height is 5. So here we're going to have 12.5.
So where are we using 3?
The D1 from here to here, wasn't it 3?
Oh, the difference. Okay.
D1 is
No, I
3,
thought
the
so.
difference.
The 9.
Okay. And here we have 7 times 5. So what do we get? See, I'm not touching this guy here until I rectify. 3 times 5 is 15. 15 divided by 7 is 2 point what? Fifteen over 7 is 2.14.
2.14.
2.14. So when we add this, we're going to get what? 14.64. This is called our mode. It carries about 5 marks. In your books at master's level, you'll be given this formula, FM minus F1 over 2 FM minus F1 minus F2 times height. To give you the same answer, our lower boundary is what? 12.5. Our FM, I said, is the highest number, which is 12 itself. And F1 is the number above, which is 9, over 2 times 12 minus 9 minus 8 times the height. You still get the same answer as 14.64. That is how we find our mode. Please, some of these things were brought by people who have died by now. So these theories, you cannot do anything by them. It's just the way you need to know them. So
the 12.5 callings I'm lost. You said it should have been the highest number, which is 12, but why is it 12.5?
12.5 is coming from the 13. We subtracted as 0.5. All right. So if we had 18 here, our D1 would have been 18 to 12 is 6. Our D2, 18 to 4 would have been what? 14. Then our lower boundary would be, instead of 18, we put what? 17.5. So don't mix the 12.5 here and the 12.5. This 12 is a 12. We already used it. It's the difference above and the distance below. Yes, Mwaka.
Oh,
All right. So now we go to the median. Median, the formula is L plus N over 2 minus FC over FM times the height. Okay. How do we get the height? The height is simply the distance from here to here. It's consistent. You can even choose it from here. So 8 minus 3 is 5. 13 minus, so it is the height throughout here, which is, you get it there. Don't subtract this and that one because it will give you 4. If it's not adjusted, it will give you a different one. But for the adjusted ones, you can subtract this minus that, you get 5. This minus that, you get 5. But I usually advise that you get the distances above any of these two strands. Is that clear? On the height, there was a question on the height. All right. So here, let's identify our N was what? So when you go to this one here, what was our total here? 39. This is the same as our N, which is 39. So the first thing, divide 39 by 2. Median means half in the middle. 39 divided by 2, what do we get?
19.5.
19.5. So 19.5, you go into this line and you see the number which is equal to 19.5 or first exceeds 19.5 is what? 27. So you draw an invisible arrow there. So you identify 3 things. The number above this 27 is called your FC, which is 15. The number next to this 27 is called your FM, which was the same as the FM we found initially. And the lower bound is what? The 13, which is 12.5. Let's try this again. If you had cumulative frequency as follows, this one here, how do we find the median? The total here is what? 50. When you add them, it's 50. The first step is you find half of 50 is what? 25. So you go to the cumulative frequency, look at the number which first exceeds 25 or is equal to 25. Ili pesa? Hapa 22, hapa mamona. You identify 3 things. The number above this 22 is called your FC. The number next to this 22 is called your FM. The lower boundary here, L, is this. Instead of 11, it will be what? 10.5. So that is why so I said this is 50, half of 50 is what? 25. Which number first exceeds 25? 34. All right. Which number first exceeds 25 is 34. So the number above this one is called your FC. So our FC is what? 22. Then the number next to this 34 is called your FM. So our FM is what? 12. Then the lower boundary, 21, but we subtract 0.5, so it will be 20.5, which is a standard. Our FM is 12. The number above this one is 22, which is our F or FC. All right, so that is how we find our median. So let's go back to our example here. I said this, our FC was 15, our FM was 12, and our L was 12.5. Okay. So L was 12.5. FC, FM, our height was what? 5. Our FM was 12. And the number above this was 15. So here we're going to have 12.5. Our N was what? 39
39.
over 2. And our FC was 15. Our FM was 12. And our height was 5. All right, information overload. I'm sure people are getting tired. So I will not proceed from here. I will at your own time allow you to finish up this to get the figure there, but I'll give you some homework to do.